we need to figure out the magnitude, direction, and the vector representation of the net force for this particular scenario. So let's try that, of course, as usual. Now we are looking at the analysis. So we have 30 Newton over here, and first thing is we need to resolve it along the x and y axis. So the first force would point in this direction and point up. Second force, say it points to the left and up, and the third force is pointing down. So this is basically 30, and this is an adjacent side, so this will be cos of 53 degree. This will be 30 opposite side, so this will be sine of 53 degree. The pink one would be 30 cos of 37 degree, and this is 30 sine of 37 degree. Right? And yeah, we have 20 Newton as well. So now the working. So first thing first, let's figure out your forces in its vector form. So we have 30 into 0.6 I cap, right? Cos 53 is 0.6 approximately. Then we have plus 30. Right now we are going with up and right as positive, guys. So this is sine 53, 0.8 J cap, so many Newton. Then F2 will be minus 30 into 0.8. This will be I cap plus 30 into 0.6 J cap Newton. Then F3 is equal to minus 20 J cap Newton. So we have the net force is equal to sum of all of the forces acting on the object. And so in this case, it will be sum of all of this. This is 18 I cap, this is 24 J cap, that's force 1, minus 24 I cap and 18 J cap, minus 20 J cap. So let's see all the I caps. So this is your I, nothing else, right? So the difference will be minus 6 I cap, indicating it's on the left. And here it would be, this will be 4 and plus 22 J cap. So this is basically pointing in second quadrant. Okay, let's figure out the magnitude and direction. So F net will be root of 6 square plus, ignoring the negative sign because anyways we are squaring it, and 0.5. And this will be how much, guys? 36 plus 484 root of 520 is 22.8 Newton. Again, I'm kind of curious about if the math will turn out right. Of course, it will turn out right, but I hope you guys are also curious about it. So we have the angle Fy by Fx. Fy is 22, Fx is minus 6. So this will be theta is equal to tan inverse of a negative value. So negative of tan inverse of 22 by 6 minus 75.4 degree. Okay. So all of these angles are measured with respect to positive x axis. So negative sign indicates it is right here itself clockwise. So if I go clockwise, 73 over here, I'll end up somewhere over here at this point spot. And if I draw a line, it would be something like this. But since our force is pointing in the second, it's over here. So basically it will be something like this. So let me write it with red. So it would be this, guys. Okay, let me write it fat. And this will have a magnitude of 22.8 Newton. So this angle in this direction would be how much? So this difference is 180 minus 75.4, 104 degrees. So this will be, theta will be 104.6, yeah, degrees. So does that make sense? Left is more over here. So this is a bigger force than the right. That's okay. That makes sense. And there's a lot of pull force. And the resulting force, yeah, it makes sense, is much closer to the y-axis than the x-axis because the x component is very small while the y component is 22. It's almost more than 3 times. So it makes sense. Okay, so that's how we can verify. Again, all of this small habit, it will add up. So you need to do all of these questions. Get used to it.